Okay, so in today's video, we're going to discuss now on how are we going to convert or translate the conceptual design to a logical design. Okay, so in our previous video, we have discussed entity relationship diagram. Okay, and that is actually our conceptual design. Okay, so what is a conceptual design? It is the one that we have discussed into our previous video. Refers to the process of creating a high-level model of the data requirements and relationships within the system. Okay, the data and the relationships within our system. The primary purpose is to create a blueprint that accurately reflects the data requirements and relationships that serve as the foundation for the logical and physical design phases. Okay, not to remove that to there. Okay, so based on the definition that we have here is we have after our this is our conceptual design, next would be the logical design and then the physical design. Okay, so first, what is a logical design? A logical design refers to the process of translating the high-level conceptual design, the ERD, okay, into a detailed, structured format that can be implemented in a specific database management system, okay, or DBMS. This phase focuses on defining the logical structure of the database, including the tables, columns, relationships, constraints, without considering physical storage details. Okay, so we are going to draw now the design of the tables, columns, relationships, and so on without the storage or physical storage details. Okay, so meaning without yet the actual DBMS. Okay, so how are we going to create or translate? Okay, that's the purpose of this video. Okay, only from conceptual into logical design. Okay, so first is we are going to divide our conceptual design into our student and course. Okay, I just covered here actually our subjects. Okay, because first is going to have our one-to-many cardinality. So going back, one course could be taken by many students. Okay, so that's why we have a one-to-many cardinality. Okay, so how are we going to present them into a logical design? Okay, so still we have the student, and I also have here the student, and the course is we have here the course. Okay, but then I presented the attributes. Okay, for example, in our course code, okay, I just name it ID. Supposedly it is course code. Okay. Okay. So the course code is now identified here as PK or primary key. Okay. And the course title or the course name. Okay. Supposedly this is a course title. Okay. Anyway, name could still do. Okay. So the ID. What is important here now is I am showing you this one here as our primary key by having now the PK here. Anyway, later on we could still add some more here. Okay, on my next example. Okay, then we have our student. So we have our student ID for our primary key, name, gender. We still have those. Then where does the relationship goes? Okay, so this relationship, a one-to-many, okay, could be represented now into our many side. Take note, this is our one side and this is our many. Into our many side, we are going to create a foreign key, okay, which is our course ID. Okay, so one course ID could be present into our student table many times. Okay, and it is our foreign key here. Okay, and a foreign key in this table here is a primary key from the lookup table. The other term now for this one is our lookup table. Why? Because what we have here is only the ID, the numbers. Okay, but if ever we want to get the name of that course, we are going to look up into this table into this ID, then get the name. Okay? So, again, one to many could be represented as, in the many side, just create a foreign key and get the primary key of the one side. Okay? So still, we have one to many relationship. Okay? So this is one to many cardinality. Okay? So how about many to many cardinalities? I'm going to show you first the ERD for the conceptual design. Okay? So many and many. So how are we going to represent this one here? Okay? That to show that a student in many student can enroll in many subjects. Okay? So we have here our logical design. Still we have the many student and the many subjects. Okay? But then we could not create a foreign key here for our subjects. Why? Again, if ever it is a foreign key, meaning it is on the many side. Okay? So we could then be creating many this is many, so therefore if again going back, if ever this is many, this take note, this is many, I'm going to create a foreign key here. So therefore what will happen is that there would be a redundant data. Why? Because we are going to be multiplying the number of records here to the number of related records in this table, and vice versa. So that is why if ever many to many cardinality, we are going to create an extra entity. Okay? So I'm just going to call this one enrolled subjects, okay, or student subject, or whatever you want to call this one, to signify that this subject is the relationship now between the student and the subject entities. Okay? Still, I have the primary key, could be just an auto increment. Okay? And I have then, since many, so I have here a foreign key for my student. Okay? So one student can have many records here. Okay? And one subject can have many records. Okay? So therefore, if a student has enrolled 3 subjects, so therefore there will be 3 subject codes here and with the same student ID. Okay? Just like with our previous examples. Okay? In which again I have shown you first the details before we have our diagrams, so that I think it is easier for you to understand the relationships that we have now. Okay, again, if ever many to many cardinality, we could not just simply use a foreign key into each of the entities, but create a new entity and then create a foreign key for each of the entities. Okay? Actually, we could still add some more attributes here. For example, date enrolled, okay, room, and so on. But anyway, I'm just showing you this one here so that we are going to have a simple, so you could easily understand how are we converting that conceptual relationship here or design here into our logical design. Okay? And the complete students database logical design is we have now this one here. One course could be taken by many students. So that is why we have here our foreign key. And a student can have many subjects. We have here now an extra entity. Okay? And one subject could be taken by many students. Okay? So this is now our complete database, complete logical design for our students database. Then for our simple or the basic library management system. So again, this is our conceptual design. So the publisher publishes book, authors, and the borrowers with the relationships and cardinalities. Okay, so we're going to have them again one by one. So first is we have book to publisher. This is actually the one to many side. Okay, so here, one to many. Okay. So we have here one to many. Again, this could still be true because it is possible that we have a publisher, but we have not recorded a book for that publisher yet. So therefore, we are going to have here a zero or many cardinality. But it is the best to have here one, at least one. Okay, again, I just pick up this line here, so I was not able to notice it is 0. Okay, but what is new here compared with my previous examples? Okay, it is dirtier. Why? I have here now the data type and some constraints. As what we have defined earlier, logical design should now include the types and some constraints. Okay, so we have here publisher ID. So we have int. Okay, the data type is integer and auto increment. Okay, then publisher name, varchar, and not null. So again, we have here one to many. Okay, so we have here also for the title is we have varchar and not null, and so on. Okay, so that is book to publisher, one to many. Again, if ever one to many, so we're just going to have an extra foreign key. How about many to many? Because many books could be written by many authors. As you can see here, many and many. Many books could be written by many authors. So we have here, if ever many to many, we are going to create an extra entity. Okay, wherein we are going to get then the primary key there, and it will serve then as the foreign key on the extra entity. So one to many and one to many. Book to author and book to borrower. One borrower can, or one or many borrower can borrow one or many books. So that is why we have here many to many. So therefore we have here an extra table or entity. Okay, I just called it transaction because we are going to record here all books borrowed or transacted by the borrower. So again, so we have the foreign key for the book and a foreign key for the borrower's ID. Okay, FK1 and FK2, and as you can see here, I have an extra attribute. Okay, and actually you can have some more attributes for. We are not limited to only this one here. Okay, and we have here the complete logical design for our simple or basic library management system. Okay, so we have here for our publisher and our book, one to many. So we have just included here a foreign key. Then for the books and authors, we have an extra entity, and the book and the borrower, so we have here again an extra entity, and depending on the extra entity, the foreign key from those foreign keys in our lookup tables. Okay, so this is how are we going to convert conceptual to logical design. And the next step here would be our physical design, wherein we are going to use then an actual database management system. And into our example, in our case, we are going to use MySQL or MySQL. Okay, so that's the end of the slideshow, and I'll see you on the next video.